Welcome, and now we're going to learn the effects of dilations on area and perimeter. After dilation, the image's perimeter is the original's perimeter times the scale factor. After dilation, the image's area is the original's area times the square of the scale factor. So the first part's in your notes, the top, the part in my handwriting there. And I want you to label, it's on the third page, and I want you to label it effects of dilations on area and perimeter. Oops. Guess I leaned a little bit and it made my writing go all pooey. All right, so you can just put this part in your notes right above this. All right, so the perimeter of the image is going to be the original perimeter times the scale factor. The area of the image is going to be the original area times the scale factor squared. All right? I want you to add this to your notes and this to your notes. All right, so just a little bit of writing there. You could probably squeeze that in on that space there or above it. All right, so for instance, if the original has a perimeter of 10 and an area of 6 and our scale factor is 3, the perimeter is going to be 3 times as large. So that means the perimeter of the image is going to be the original, which was 10, times the scale factor, and so that one's going to be 30 units. But the area is going to be 3 squared, or 9 times as large. So if the original area is 6, the area of the image is going to be 6 times 3 squared, which is 6 times 9, or 54 units. Right? So you don't even have to know, units squared, you don't even have to know what the figure even looks like to be able to find the area and the perimeter of the image, so long as you know the scale factor, or even go the other way. Right? If you knew the perimeter of the image was 30 and your scale factor was 3, you would just divide 30 by 3 and that would give you 10. Right? So we're going to do some on a coordinate plane. We're also going to get to practice a little bit of dilating around the origin as well. And one of these is in your notes on the third page, and I think it's not this one, it's the next one. All right, so we're going to draw the dilation image of rectangle ABCD with the center of dilation at the origin and a scale factor of 2. I have the coordinates listed there, and just in case my figure moves at all, I'm going to put those in there nicely so we can see them. All right, so A there is located at 1, 3, B at -3, 3, C at -3, -1, and D at 1, -1. All right, and we're given the scale factor. The scale factor is 2. So to find the coordinates of the image, since it's around the origin, we just have to multiply the coordinates by the scale factor. So that means our image is going to be located at, so we're going to multiply 1, 3 times 2, so that would be 2, 6. And then -3, 3 is going to be -6, 6. And -3, -1 is going to be -6, -2. And 1, -1 is going to be 2, -2. We simply multiply all of our coordinates from the original by the scale factor. All right, so what we learned on the last page, and I have the perimeter and area right here so you can even see that, our perimeter is going to be 2 times as large. The area is going to be 2 squared as large, or 4 times as large. So let's graph our image. All right, so 2, 6, 2, 3, 4, 5, 6. All right, that'll be A prime. And then -6, 6. So 3, 4, 5, 6. 1, 2, 3, 4, 5, 6 right there is B prime. And then C prime is going to be at -6, -2. And D prime is at 2, -2, right there. Right, so all the distances are twice as far, which means our perimeter is twice as much. All right, there we go, there's our image. All right, but you might wonder why the area isn't twice as much, but it's 4 times as much. Well, think about how you find area, right? You multiply one side by the other. So now you've increased, let's say this is our base, and this is our height. All right, so you have the original, right? And you've multiplied that by 2. So this one's going to be twice as large as the original. I'll put two pre-images, right? And the other side is going to be twice as large as the pre-image. So you're going to have, so if you found the area, your area would be your base times your height, which means you'd have 2 pre-images times 2 pre-images. And that's going to give you, and that's where the 4 comes in. All right, and so the original, so the P there, we had 4 and 4. All right, so 4 times 4 times 4, and that's why it is 64. 4 times as large, right? That's just where that number comes by. So since you're making 2 sides as large, when you go to find the area, when you multiply them, your area is going to be 4 times as large. And we can see that from our diagram here. So the perimeter on the original, this did happen to be a square. So you just take your side measure times 4, right? They were each 4, so 4 times 4 would be 16, right? And it so happens that the area is the same thing because it was 4, right? So because 4 squared and 4 times 4 are the exact same thing. And so 4 squared gives us 16. So the perimeter of our image is going to be twice as much. Right now the sides are all 8, right? So each one of those sides is 8. So there's 4 of them. So now the perimeter is 32. But 8 squared now gives us 64, 4 times as large. All right. By the way, the steps for computing dilations, if the origin is the center of dilation, are in your notes. They're on the next problem. And so each time we'll do the exact same steps so long as we're dilating around the origin. And that is listing all the vertices of the original object as a matrix, which was already done. Identifying the scale factor, which I already did. And then in this example here, we multiplied the coordinates of each point by the scale factor if the center of the dilation is the origin. The coordinates multiplied by the scale factor will be the location of the dilated image, right? So that's what we got when we multiplied by the scale factor. We identified all the coordinates with a prime symbol, and we graphed the image, right? So we did all the other things. All right, let's do another one, and the next one's in your notes. All right, so same figure there. Did I move it? Oh, except I moved it. Same figure, except I moved it. Over to 6, 6, 2, 6, 2, 2, and 6, 2. Same square though. Just new location. And this time our scale factor is 1/2. All right, so notice, I don't know that this is in, I think, yep, this is in your notes as well. I'm looking right here. So our scale factor is between 0 and 1. The image is going to be smaller than the pre-image and closer to the point of dilation. All right, so to find where our figure is located, all right, we already listed all the vertices. We already identified the scale factor. I have it written in there as a scalar multiple. And now we're going to multiply the coordinates of each point by the scale factor since the center of dilation is the origin. All right, so 1/2 times 6 and 6, that's going to be 3 and 3. Half of 2 and 6 is going to be 1 and 3. And then multiply 2 and 2 by 1/2 and 6 and 2 by 1/2. All right, so here are our new coordinates. Let's graph those. All right, so we have 3, 3, and you'll graph it as well. Right there is going to be A prime, 1, 3, right there will be B prime. C prime is located at 1, 1. Right? So notice that it's half as far away from our center of dilation, which is the origin. It's easy to see that in that point. And then 3, 1. Right? So right here is D prime. All right, so here is our image. Right? Notice it is smaller. Notice it is closer to that point of dilation. It's twice as close. Right? Because our scale factor was half. All right? So, or it's half the distance, however you want to think of it. All right, so our perimeter is just going to be the scale factor times greater, right? So it's half a times greater, right? Half as much, however you want to word that. The area is going to be 1/2 squared, which would be 1/4. And let's see if that's what we have. All right, so our perimeter, same figure except it was moved. All right, so, and it was moved so you had nice even numbers there. So the perimeter, each of the sides in the original was 4, right, and it was a square. So 4 times 4 is 16. The perimeter of the image, right, each of our sides now is 2. There's 4 sides of 2, right, and so the perimeter is 8. Notice it is half as much. Right, on the original, since our sides were 4, the area was 4 squared, so it was 16. On the image, right, each of our sides is 2, right, and so 2 squared, or 2 times 2 is only 4. So notice that the perimeter is half as much, but the area is 1/4 as much. Right? And that's how it'll always be for dilations, and whether they're around the origin or not, but I happen to do these ones around the origin. In the next podcast, we're going to be looking at what if the center of dilation is not the origin. What do we do then? All right, thanks for watching. Bye for now.